The following program is video supplemental instruction. VSI is brought to you by the Teaching Center, UF's Learning Support Center, www.teachingcenter.ufl.edu.
Number 4 for the same exam. Mars has about 1/10 of the mass of Earth and about 1/2 the diameter of Earth. The acceleration in meters per second of a body falling near the surface of Mars is about what? So we know that G is equal to 9.8 meters per second, G of Earth, right? 9.8 meters per second squared. So, we know that mass of Mars is equal to 1/10 the mass of Earth, right? And the diameter of Mars is equal to 1/2 the diameter of Earth. So, what can we do with all this? We know that to find the mass or to find the force of gravity, we know the equation force of gravity is equal to G mm over r squared, right? So if we want to find what the acceleration is, we also know that F is equal to ma, so to find a, we divide everything by m. So that means that to find the acceleration due to gravity, we divide everything by the mass, that mass. So we get g m over r squared, right? So, from here, we know this is for Earth. Okay? So for Mars, we need to find the acceleration. Sorry that I'm writing so badly. AG is equal to G times 1/10, because it's 1/10 the mass of Earth, 1/10 the big M, the mass of Earth, all over 1/4. Oh, no. 1/2 r squared. We know that diameter is 1/2 of the diameter of Mars is 1/2 the diameter of Earth. The radius of Mars is going to be 1/2 the radius of Earth. So that means that we're going to be able to assume that, plug that in here. But it's squared, so that's going to make a difference. That's oftentimes where people make a mistake, is when it's squared for a variable. So this turns into G m over r squared times 1/10 in the numerator, 1/4 in the denominator. So that means that it's going to be 1/10, 1/4. That means it's going to be 4/10 G m over r squared. And this is in terms of the Earth, because this is all in terms of the Earth. That's why we have these ratios. This is of Mars, that's of the Earth. So then now, we know this is to the acceleration of the Earth. So to get the acceleration of Mars, this is the acceleration of Mars. And this is the acceleration of Earth. So that means that we have to multiply 9.8 times 4/10, which equals to 4, which equals to around 4 meters per second squared. Okay? That's the answer we're looking for. I made it a little bit more complicated than you had to be because I wanted to show you how to plug in variables and substitute so that you can do these kinds of problems. Generally when you have, as a disclaimer, generally when you have questions like this where there is almost no numbers given, you're going to have to use substitution and comparison of equations. You're going to have to use variables a lot and do this kind of stuff just because it's more conceptual.
The Teaching Center, UF's Learning Support Center, www.teachingcenter.ufl.edu.